Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Hoffmann exhaustive methylation, Hoffmann elimination, involves 1. Quaternizing the amine with excess CH3I to form a quaternary ammonium salt. 2. Treating with Ag2OH2O to convert the iodide to hydroxide. And 3. Heating, pyrolysis, to cause elimination, producing an alkene via an E2-like mechanism that favors the less substituted, Hoffmann, alkene. Step 1. Identify the starting amine. The compound is Me to CH to NH to CH to Me, a secondary amine. The nitrogen is connected to two carbon chains. Chain A, CH to CH, Me, 2 isobutyl group, I, CH2 CH Me 2. Chain B, CH to Me, N-propyl group. Step 2. Quaternization. Excess CH3I methylates the nitrogen fully to give the quaternary ammonium iodide, Me to CH to N plus, Me, CH to Me, CH3I. Actually N gets to methyl groups added to reach quaternary, Me to CH to N plus, Me to CH to Me, I. Wait, it's a secondary amine so needs to CH3I to become quaternary. The ammonium salt is Me to CH to CH to Me, Me to N plus, I. Step 3. Conversion to hydroxide with Ag2O. Step 4. Hoffmann elimination, pyrolysis. Hoffmann elimination preferentially removes a proton from the beta carbon that is least substituted, least hindered, giving the less substituted alkene. The nitrogen in the quaternary salt has 4 groups. 1. CH to CH, Me, 2. Isobutyl the beta carbon to N is CH, Me, 2, which bears to methyl substituents, tertiary H, more substituted. 2. CH to Me, N-propyl the beta carbon to N is CH to Me, which bears 1 methyl, secondary H, less substituted. 3. 2 CH3 groups, no beta H available for elimination. Methyl groups have no beta carbon relative to N in the elimination sense. Actually CH3 attached to N has no beta H. Hoffmann's rule, elimination occurs toward the less substituted beta carbon. Between chain A, beta carbon is CH Me 2, tertiary, and chain B, beta carbon is CH to Me, secondary. Hoffmann elimination favors chain B because it gives the less substituted alkene. Elimination from chain B, CH to Me removes H from the CH to Me, beta carbon, to give CH2 is equal to CH Me, i.e., Me CH is equal to CH2, propene 1 propene, with loss of the amine fragment. This matches option A. Me CH is equal to CH2. Why other options fail? B. H to C is equal to CH2, ethylene, would require elimination from an ethyl chain, but there is no ethyl group directly. The N-propyl group gives propene, not ethylene. C. To methylpropene, Me to C is equal to CH2, would be the Zaitsev product from the isobutyl chain, but Hoffmann elimination avoids the more substituted alkene. D. CH3CH, Me, CH is equal to CH2, 3-methyl, 1-butene, would come from elimination at the terminal position of the isobutyl chain, but the isobutyl group's structure Me to CH2 has no beta H on the terminal side that would give this product under Hoffmann conditions. Therefore, the correct answer is A. Therefore, the correct answer is option A.